Okay, so next up on our list is polyatomic ions. So how we know a compound is a polyatomic ion is that it's going to have three capitals. So if I have MgSO4, I have three capitals. M, S, and O, three capitals. That means it's a polyatomic ion. Another example might be MgOH2. Again, three capitals. M, O, and H, polyatomic ion. It can have more than three capitals, that's okay, but if it has three or more, it's definitely going to be a polyatomic ion. If I have MgCO3, same thing, polyatomic ion. Attached on Google Classroom is your whole big list of your common polyatomic ions. Both columns are the same, but one is in order from A to Z, and then on this side, it's the compounds in order from A to Z. Okay, so both sides are the same, just in different orders. So we're gonna learn how to name these compounds and how to come up with formulas. So another big thing to notice is that all of these names don't end in IDE. We have ite or eight, 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 peroxide, I guess there isn't ides there, ite, eight. So a lot of them are gonna end in either ATE or ITE. Not a lot of them end in IDE. Okay, so they're gonna be different compounds mixed together. So take a look at this sheet, get familiar with a few of them so that we know how to recognize these. So if I give us the compound, I guess we'll just take one of these ones up here. If I give us MgSO4, we know that Mg is magnesium, SO4 is another compound, and we're gonna look on their sheet for SO4. So SO4 is way down at the bottom, called sulfate. So we said that Mg was magnesium. And then SO4 we found over here again, that was sulfate. So this compound is literally just called magnesium sulfate. Next one up there, we'll take MgOH2. Actually, let's change this. Let's do Na. Can we do Na? We'll do BE. Let me just change those together. All right. We'll do BeOH2. So we know that Be is beryllium. Found that on our periodic table here. So beryllium. And then OH is not a periodic table element. It's going to be on our common polyatomic ions. OH is right here, and it's called hydroxide. So it's going to be beryllium. ERYLL, beryllium, and then hydroxide, HYDROX, hydroxide, just like that. Next one we'll do is CaCO3. So Ca we know is calcium from the periodic table, right there. And then the next thing we have is the CO3. So CO3, again, is not on periodic table. It's going to be on our common polyatomic ions. CO3 is right here, called carbonate. So calcium carbonate, C-A-R-B-O-N-A-T-E, just like that. Calcium carbonate. So again, polyatomic ions are going to have three capitals. They're usually going to end in ITE or ATE, or ITE. We name them by just naming the metal first and then naming the polyatomic ion second. Metal first, polyatomic ion second, and again, metal first, polyatomic ion second. Coming up with the formula is also just as easy. So if I gave us potassium nitrite, N-I-T-R-I-T. As soon as you see that I-T-E, you know that that is a polyatomic ion. And potassium, we also know is K. So potassium is K. Nitrite, we know to look at this sheet and find the word nitrite. Nitrite is right here as NO2 with a minus sign. So NO2, and it has a charge of negative. We also know the potassium has a charge of a positive. When we make their formulas, we just cross them like we usually would. So it's going to become K. One goes over here, NO2, and the one goes on the K. Just like that. Another one could be boron. Boron dichromate. D-I-C-H-R-O-M-A-T-E. So boron is one of our classic metals, but dichromate does not sound familiar, therefore it's going to be one of our common polyatomic ions. So dichromate is right somewhere here, right here. So boron we know is B, and boron's charge is 3 from the periodic table. Dichromate was Cr2O7 with a charge of 2 minus. So when we go to cross those, we drop the signs and we cross the numbers. So it's going to be B with the 2. One thing you have to worry about here is that you have to have brackets around the Cr2O7, and then the 3 goes on the outside, because that 3 has to be on this whole compound of dichromate. So the 2 goes on the boron, the 3 goes on the whole dichromate. If the brackets are not there, it is wrong. You need to have those brackets. Okay. Another one, if I do nickel 3, arsenate, A-R-S-E-N-A-T-E. So we notice that nickel has a Roman numeral beside it. That means it's a transition metal, which it is. We found it in the middle here is nickel. The charge on it is going to be 3. So Ni with 3. Arsenate is not an IDE, therefore it's going to be a polyatomic ion. And then we find it up here, arsenate. It is AsO4 So AsO4 minus. Again, we're going to drop the signs and then cross the charges. Ni with this 3, brackets, AsO4 with this 3. However, because they're both 3, we can reduce those to NiAsO4, both 1s. And you don't need the brackets when you have the 1s. You can put them there if you like, and then put a 1, but again, it will normally not be written like that. So you can also make polyatomic ions, as we just seen, with some of our transition metals. That is okay, you can mix them together. You just gotta make sure that you watch out for your Roman numerals. So again, take a look at this sheet to be familiar with lots of these ions. A reminder that most of these ions will be 3 capitals, and they'll have ending in ATE or ITE.